Okay, moving on to the next, that a 4,1 plexer is for generate the output carry of a full ladder. A and B are the bits we added while C out is A and B are used. Right. The question says that these are the input. This is multiplexer. It is just nothing but a full adder. A full adder basically takes A and B as input, seen as another input. Adder means taking 3 input bits and giving output as a sum and carry. But here they are saying that they are just taking the carry output, the C out. They just make the truth table of a full adder. A, B, put C out. Right. Now in this case, first case, if we add them up, the carry will be, second case, 0 carry. The third case is 0 carry. Now fourth case, 1 plus 1 will be equal to 0 and the carry out will be 1. 0 carry, again 1 carry, carry 1 and carry 1. Carry outs are at these positions. At position number 3, at position number 5, at position number 6 and at position number 7. Now, okay, when they are asking you to find out, like these two are select lines and one of them you have to take out the, these two are select line already given, right? In this case, how to find out the output, right? So in this case, this is what is happening. From input I0 to I3, I have to put input C input in such a way that C out will be there. C out is there when terms are 5, 6 and 7, right? The best way to draw it is write input here like this. Put this as C bar, put this as C, and similarly 0, 1, 4, 5, 6, put ones at your selected terms. So this is your selected terms when C out is equals to 1. C out is equals to 1 at 3, 4, 6, 7. C out is equal to 1 at 3, 4, 6 and 7. So 3 is 1, 4 is 1, sorry, not 4 is not 3 is 1, 5 is 1, 6 is 1 and 7 is 1. Now here they are 0, 0, 0 and 0. So in this case, the final output, we write it like this. So I0, both are zeros, so I0 will be 0. In I1, C in is 1, so C in will be I1. In I2, again C in is 1, output. In I3, both are 1, so C in will cancel out C in bar, so output will be, so I3 will be 1 only. So this is how we will be putting the inputs. So I0 is equals to 0, seen, this is also seen, and this is equals to 1. So which option matches? So option A will match. First find out the truth table. And in this case, if one of the input segment, if A, B and C in should be the input to a truth table of full adder, right? And output is carry out, right? We have taken the carry out. Find out the expression, find out the values on which the output is equals to 1. If two of them are used as select line, and you have to find out on which line we have to put the input in order to get the output as carry out. So we have found out from the truth table that C out will be 1 when it is 3, 5 and 6. This is how we make a table like structure for I0, I2, I1, I2 and I3. What is the left out input? So left out input is seen only if two inputs seen as seen are, because it can be 1 or 0 both the ways. Whatever value we get, put those values at the place values. So it is 1, 1, 1 and 1 like this. And if any of 1 is there, any of 1, which if it was 1 at this position, right? So if it was 1 at this position, what will be? Would have selected seen, but here 1 is at this at C. Here also output will, if both are ones, then the output will be 1 only. How we solve such kind of questions? These kind of questions means basically we have total of 3 input, 2 is given as select line, and third we have to select from the input lines which are like I0, I1 and I2 and I3 in order to find out the output. Just draw truth table. Two are there as select lines only, and third. Okay, next question. Next question says that you have to identify. So the circuit below basically is 3 cross 8 and 8 cross 3 encoder. So basically whatever we are giving as input, it is giving some output y2, y1 and y0. How we will be solving it? So this is output number 0 and this is connected to input number 0. I am writing output here of encoder and input of encoder. Output will go. Right, these are the outputs. It is connected to directly to input. First one is 0, 0, 0 only. Next one is directly to input 0, 0, 1. Next one is connected to output 3. So basically it will be IP3 means output 3. So 1, 1. Right. And this is connected to input 3. Inputted to output 3 is connected to input 3. Basically 0, 1 and so on. So this is what type of coding they are saying. So let's just try first. Gray codes 0, 0, 0. How we find out gray codes? Just write first MSB bit as it is and take XOR of simultaneous bit. 0 XOR 0 is a 0. Again 0 XOR 0 is 0. For 0, 0, 0, gray code is also 0, 0, 0. Next number. Number is 0, 0, 1. First number as it is 0 XOR 0 is 0. 0 XOR 1 is 1. Also again for 0, 0, 1 it is gray coded as 0, 0, 1. Okay. Next one. So it is 0, 1, 0. 2 is written as it is. 0 XOR 1 is 1. Again 1 XOR 1. It is coded as 3. It is 3 because it is connected as connected to 3. Output is connected to 3. Basically 3 will be 0, 1, 1. So what we see here, it is following what? Binary to gray code pattern. Binary to gray code pattern. Let's just check other. So x is 3. X is 3 means 0 plus 3. If it is 0, 1 plus 3, 2 plus 3. This kind of pattern we are not seeing it here. Gray to binary, it's not going opposite. Otherwise, because we are taking here 0, 1, 2, 3 in respective numbers, and here inputs are changing. Okay. This is what type of encoder? This is binary to gray coder. It works like the decoder. So when I am saying that it is 0, 0, 0, the inputs are 0, 0, 0, output 1 will be selected. If I am saying it is 1, 1, 1, output 7 will be selected. And encoder works just opposite. So if I am selecting this, output will be 1, 1, 1. If I am selecting this, the output will be according to 4, that will be 1, 0, 0. But here, instead of 4, output 6 is given. Basically, 6 is coded as 4. This is what type of coding? Is gray coding, as we have seen here. Okay. Okay. Moving on to the next question. Question number 11. A 1 to 8 Dmax with data input as D. Traces input as S0, S1, S2, where S0 and Y0 7 as the 8 Dmaxed out. They are in bar. Okay, so we are taking the inverted output. Is to be designed you. Now they are saying that the above description of a demultiplexer, they are designing it by using 2x4 decoder, right? The similar type of structure they are designing. 2x4 decoder, there will be requirement of 2x4 decoder. Outputs are 8. Okay. In this decoder, equations are equal is E. Address inputs are A0 and A1 as shown, and inputs are D in S2 are connected to RS but not necessarily in order. Have to find out the respective input connections to PQRS terminal should be. Okay, so now they are saying that there is a multiplex having as a D in and 3 select lines. There will be 8 output from Y0 bar, Y7 bar, and this is connected. This is formed by 2 decode, which we have created 4 input RS and given some terminal randomly set to these. Have to find out the perfect connections, that P is equals to some S0 or a D in value, that what value is this. Similarly for Q, R, S, right? So let's just see that how we do. Now if I draw for Dmax, I'm just writing some input. So for Dmax, output Y0 bar should be equal to, when D in is given and all the select lines are selected to 0, right? Then output Y0 will be selected. So it will be D in and all the select lines should be equal to 0, and it should be whole bar because we have to get the value Y0 bar. So if I open it, so it will be D in bar plus S0 plus S0 bar S bar. So this is your Y0. Similarly, you can find out the other values. Similarly, if I write Y1, it will be D in S0 bar dot S1 bar is set as 1. It will be S0 dot S bar dot S2 bar whole bar. So it will be in plus S0 bar plus S1 plus S2, right? Similarly, let's just write two more terms. Y2 bar, it will be equal to D and select line should combine to 2. So it will be S0 dot S1 dot S2 bar, because 1 is positive, it should be 2. If I take the whole bar, so it will be equal to D bar plus S0 plus S1 bar plus S2, right? Because S2 bar bar, S0 bar bar. So this is how we can find out the outputs of demultiplexer. We have to compare it with our encoder output. Encoder outputs. Okay. Moving on to a 1x8 data input with S0 as LS and Y0 to Y7 are in bar as outputs, right? It to be and it is to be designed using 2x4 decoder, and which is filled with input with E, and input are shown in the figure, right? Being S0, S1, S2 are to be connected to RS, but not necessarily in order. And what is the order rule, right? So what they are given is, so question says that one cross 8 Dmax in which D is input and S0, S1 and for select lines, which will give output from Y0 to Y7. They are in bar, not Y7. Here, input Y, when output Y0 will be selected when select lines are 0, 0, 0. Similarly, output Y7 will be selected when select lines are 1, 1, 1, so on. Intermediate will be 1 will be selected when it is 0, 0. Repeated S0 is the min term, the least significant bit, so it will be 1. So that will be Y1, right? So how Dmux will work. When select line will make a combination of 1, output line 1 will be selected. When select line make a combination of 4, output 4 will be selected, and so on. So this is how Dmux is worked, right? Dmux output are achieved. Let's just talk about decoder. Decoder is, given decoder is 2x4. One is enable. So enable should be, if it is low, it should be always low. That should be E bar in order to select that decoder, and some inputs A0 and A1, and there are 4 outputs. So according to combination of input, output will be selected. Suppose input are 0, 0, output 1 will be selected. If they are 0, 1, output 1 will be selected. If they are 1, 0, then output 2 will be selected, and if they are 1, 1, output 3 will be selected. This is how working of Dmux and decoder are there. Easy. And this is there, the question is saying that this Dmux is connected to this decoder. Basically, they are converting this Dmux into two 2x4 decoders, right? And the inputs are this decoder PQRS. So that they both work in the same fashion, you have to give these D in S0, S lines to PQR and S. Easy. Basically, they are converting a Dmux into two 2x4 decoders, giving output 0, 8, simultaneously here, and they have 3 select line and 1 input. You have to just draw the same line in between and P, Q, R, and you have to tell that which line should be whether it is D in S0, S1, S2, which line will be connected to R, which line, right? Okay, we just see that how we will get output Y naught. Y naught bar, I'm just talking about Dmax for now. Y naught bar will be D in, put will be there, and the select line combination should be, they both should be, they all of 3 should be equal to 0, right? And it should be whole bar because output is logic 0 activated at low. Y naught bar basically telling us about we are getting inverted output. Y naught will be D in bar plus S naught bar and bar plus S1 bar and bar plus S2 bar and bar. These 2 bar will cancel out and will give the original value. So that will be D in plus S naught plus S1 plus S2. Right, this will be Y naught. Similarly, let's just find out Y1. Y1 will be D in, here S naught will be 1, S1 and S2 will be bar bar. So it will be D in bar plus S naught bar plus S1 plus S2. Similarly, Y1, Y2 we can calculate. So that will be also D in bar. Here, this will be 1. So it will be S naught plus S1 bar plus S2. Similarly, we can find out, we just find out Y4. So that will be D in bar plus S naught will be 1. So it will be on bar. According to this logic, whichever is 1, it will come on bar, and which term is 0, it will come under no bar, right? So this is how we will be getting the outputs of Dmax. Let's just find the output of decoder. I am writing the output of Dmax here so that I get the clear comparison. So I am writing Y naught will be equal to D in plus S naught plus S1 plus S2. Y1 was D in plus S naught plus S1 plus S bar. Y2 was D in plus S naught plus S1 bar 2. Similarly, Y4 was these D's are in bar. D in plus S naught plus S1 2, and 2 was in bar. S was in bar because 4. Right, these are the output of, we'll have to get a similar output relation from these decoders in order to compare the result of PQRS. So this is enable, so this is P plus Q, and it should be on bar because it is enable low. This is R, S, this is again enable, so this is what, this is given as Q bar, so this is P plus Q bar and whole bar in order to enable it, and this is again R and. Now if I make logic Y naught, so Y naught will be selected when both of them will be equal to 0. So it will be P plus Q bar plus R plus S, and that will be whole bar. If you solve it, it will be P plus Q bar and bar plus R bar, S bar and bar. So double bar will cancel out, plus Q plus R plus, this is what a first relation I am getting corresponding to Y naught, that is P plus Q plus R plus S. Let's just find out Y1. Let's just find out for logic 1. Y1. Okay. Y1 will be selected when this will be equal to 1 and this will be equal to 0. Since it is A naught be equal to 1 and A1 should be 0 in order to select Y1. Y1 is selected at 0, 1. It is selected at 1, 0. At 1, 1. Selected as 0, 0. Y1 will be selected at 0, 1. So now P plus Q bar is the enable. We know it. R should be 1 and S should be 0. Whole bar. So it will be P plus Q plus R bar plus S. Now I'm writing it here. P plus Q plus R bar plus S. Similarly, writing out for Y2. It will be P plus Q bar plus. So now, in order to select the third output, that is Y2, it should be equal to 0 and it should be equal to 1. A1 should be equal to 1 and A0 equal to 0. So it will be equal to R bar plus S and whole bar, right? So it will be equal to P plus Q plus R plus S bar. Here it was R bar. P plus Q plus R plus S bar. Next, let's just find out Y4 also. So Y4, it will be selected like this plus R bar plus S bar and whole bar. So P plus Q whole bar plus R bar double bar R double bar plus S double bar. That will be, if I open this to P bar dot bar plus R plus S, right? It will be P bar left with much of the space here. So I'm writing it here. P dot P bar plus bar plus R plus S, right? So it will be P bar dot Q plus R plus S. Applying De Morgan again, so it will be P plus Q bar plus R plus S. This term will be P plus Q bar plus R plus S. Now we can compare and let's just see that what value belongs to. Now for the first one, it is just PQRS. We can find out that what. Now next one, along with D in, there is a slight change in S naught. Here R naught is there. Okay, R bar is there. So S naught bar is equals to R bar. So that means what? S naught is equals to R. Here S1 bar and S bar is there. S1 bar is equals to S bar. That means what? S1 is equals to S. Lastly, S2 bar, Q bar. S2 bar is equals to Q bar. That means what? S2 is equals to Q. And last term, T is equals to D in. Right. So how we will be putting the values. They are asking in respect to PQRS. So P is D in, Q is S2, R is S naught, S is S1. Option number D, correct. There. I have just took random values from this. I have calculated all the results. So you can take any two from this, any two from this. But at least you need 4 values because there are 4 variables. So I have took random 4 variables and random 4 values and from random 4 values, I got the result. You can also take random 4 values out of these combinations. If you don't get random if you don't get the clear picture, you just draw more, but you will ultimately get clear picture after these comparison. So after this comparison, I have found out this, that this belongs to this and C in line, right? Moving on